Yeah, for your information, everyone, now we are on the live YouTube live.
Okay.
It will start exactly at 7 p.m. Okay, but we are already
Yeah.
started. It will come live on 7 p.m. exactly.
Okay. Okay.
ये यूट्यूब लाइव में है, ये स्ट्रीम स्टार्ट हो गया, बट एग्जैक्ट 7 o'clock का टाइम है ये एक्चुअल से.
Hello.
Yeah, it's started. Yeah.
Ah.
Hello everyone. I think we are on the live now. I think we can start it actually.
Yes, sir. క్లిక్ చేసినారా క్లిక్ చేసి మళ్ళీ ఏదో వర్డ్ ప్యాడ్లో ఓపెన్ చేయాలి.
Hello sir. Actually, we are on the live now. Okay.
సార్
We can start the session.
Yes, yes, sir. Please, Harish Reddy, mute yourself.
ఓకే థ్యాంక్ యూ సార్ థ్యాంక్ యూ.
We will wait for 2 minutes. Let's participants join.
We are expecting 100 to 200 minimum. Let's see. 600 people has been registered. 51 watching now. 5 minutes. But I muted here, no problem. I muted. Yeah. कोणतं बी चाय ला दो.
Good evening to all the participants. We will start the session within 1 minute. So during the session or at the end of the session, if the participants are having any query, you can post your queries in the live chat box.
Recording in progress.
मैं यहाँ के एक अगर 1 आवर का सेशन करना है तो 15 मिनट्स में 2 पर्सपेक्टिव्स अगर कई तो जो नाम आप देना उसको जज करना टाइटल कई तो एक आ जाके हमारे करियर्स को कैसा इम्पैक्ट करा वन थिंग दूसरा हो जाके टेक्नोलॉजी वाइज क्लाउड फील्ड वर्क IT इंडस्ट्री में क्या पोजीशन रखा है और कितने दिन लाइव रहने वाला है तो एक ब्रीफ जर्नी ट्रेडिशनल डेटा सेंटर से वर्चुअलाइजेशन से क्लाउड टेक कंटेनराइजेशन फील्ड वर्क जो ट्रेंड चल रहा है.
So let me start. Myself, Dr. Abid Nayeemuddin, Associate Professor in the Department of Electrical and Electronics Engineering and the convener of this workshop. So I hope my voice is audible. Can someone respond?
Yes, you are audible.
Yes, audible.
Yes, yes.
And also on the YouTube live also it's audible.
Yes, thank you very much. Thank you very much. So, first of all, I would like to thank our Honorable Chairman of G.Pulla Engineering College, Sri P. Subha Reddy Garu, respected Principal Dr. B. Srinivas Reddy Garu, Head of the EEE Department, Dr. K. Sri Gauri, Head of the ECS Department, Dr. R. Praveen Sam Garu, eminent faculty members, dear participants, good evening to all of you. It gives me a great pleasure to welcome all the participants to this 1 week international level workshop on opportunities and challenges in IT sector, the Software Mastery Bootcamp to unlock your potential during 6th March to 11th March 2023. The workshop is being organized by the Department of Electrical and Electronics Engineering in association with the Department of Emerging Technologies in Computer Science of G.Pulla Engineering College, Autonomous Kurnool, and in association with Microcare Academy, Kurnool. I am very happy to share that we got tremendous response from the participants. A total number of 596 participants have been registered for the workshop. And now I take it a privilege to give brief about the workshop. This workshop is meant to disseminate the knowledge in the field of data science with special reference to modern technologies. Evolution of technology has generated a lot of data, where most of these data are not structured. Internet and Internet of Things produces huge amount of data every day that is measured in zettabyte, a unit of information equal to 1 sextillion, and that is 1021 or strictly 270 bytes. Therefore, we can't rely on the traditional data processing system. Data science is the area of study which involves extracting insights from vast amounts of data by the use of various scientific methods, algorithms, and processes. It helps you to discover hidden patterns from the raw data. Data science is the field which provides the developer a highest package in the IT industry. The child of data science is machine learning, which is used in internet search engines, email filters to sort out spam, websites to make personalized recommendations, banking software to detect unusual transactions, and lot of apps on our phones such as voice recognition or text recognition, etc. Another branch of data science is the deep learning, which is a part of a broader family of machine learning methods based on artificial neural networks with with the representation learning. Learning can be supervised, semi-supervised, or unsupervised. Deep learning utilizes both structured and unstructured data for training. Practical examples of deep learning are virtual assistants, vision for driverless cars, money laundering, face recognition, and many more. In this workshop, you will learn opportunities and challenges in various IT fields such as cloud services, database admin, data science, data analytics, machine learning, etc. The duration of this workshop is 1 week with a 1 day holiday, that is on 8th of this month, Wednesday. So a session per day has been scheduled between 7 p.m. to 8 p.m. 5 days. That is Monday, Tuesday, and then Thursday to Saturday. The sessions will be handled by the experienced and experts from IT persons. The detailed day-wise report schedule has been already shared in the WhatsApp group. With the support of our college management and Microcare Academy, this workshop is going to start from today. I hope that with all your support and encouragement, this workshop is going to be a grand success. Also, I request all the participants to utilize this opportunity and get benefit from the workshop. I request all the participants to attend all the 5 sessions and stay online. And if you are having any doubts, use live chat to ask any queries. The feedback link will be shared at the end of the session in the chat window only. So the participants who attended who maintained 60% of the attendance, that is at least who attended 3 sessions, and on the Saturday we will be conducting in addition to the feedback, we will be conducting a small quiz. So the students must store, though the participants have to score 60% of the marks in the quiz. So automatically you will get the participant certificate at free of cost. Now let me introduce today's speaker, Mr. Mohammad Ismail. Obtained his graduation degree BE in Electronics and Communication Engineering from Usmania University, Hyderabad. He also done PGDM Analytics from IIM Ranchi. He has overall 12 plus years of vast experience in IT industry. Previously, he worked on data science with Infosys, ICICI Bank, and Bajaj. Currently, he is working with Blend 360 as a manager data science. I welcome Mr. Mohammad Ismail, sir, for accepting our invitation, and I am very on behalf of our GPREC and Microcare Academy. I am very much thankful for readily accepting our invitation and for your time to handle today's session. Now let me end with this my report with this well-known quote: engineering is the art of directing the great sources of power in nature for the use and convenience of man. Another famous quote I will share: engineers are the builders of tomorrow. So with this quote, I am closing my opening sessions. Thank you very much. Now I am handing over the session to our today's speaker, Mr. Mohammad Ismail.
Thank you, Abid Khan. Thank you, everyone. Thanks for joining in. Without taking much time, I will go directly start the session. Thanks for the introduction. The details have been shared in a very brief and good manners with Abid sir. So going into today's session, today we plan to start with understanding what data is. We'll talk about the data as such, how it is being used, what is the landscape of big data, and then before we go into the details of AI and ML, I just want to have a brief on what data science, AI, ML stands for, understanding those correct definitions of AI, ML. Then we look into some of the use cases of machine learning and AI and go into how we build data science solutions on day-to-day basis. And we end this session with seeing some of the case studies or some of the projects that we have done recently. So this is what our agenda will be. To start with, the agenda for myself is already being explained, so I will skip that. Now, how the data was maybe 10 years back. So this is some of the example about the data. Now, when we were sitting 10 years back, maybe in 2013 or 2010, going back some couple of years back, if you wanted to know about a customer, what we had was mostly about his education, about his addresses. Uh, it would be like a very important information about what he likes, what he dislikes. Now, this is only the information or the data about a customer that used to be, and maybe 10 more facts about you or a customer. Now, this is everything that a company used to know about a customer 10 years back. Now they know what your education or experience, but also they know about what hobbies do you have, what do you do in your free time, what do you search on different websites. They know your online behavior, offline behavior. They know your shopping habits. They know about your living. They know about your preferences, and even more, they know 10,000 more different facts about you that we even aren't aware of. Sometimes you aren't aware of things that the companies know about us. Now, this is how the data is expanded. Now, with this huge chunk of data, which is getting generated every year, so this is what the data is right now. So, if you see over here, the blue line at the bottom shows you how much data is needed to store 100 years of high definition video and audio. Now, the interesting thing about this graph over here is the axis on over here, the y-axis, is not a linear scale. It is a logarithmic scale. That means that the amount of information which is being shown over here, 1 petabyte to 1 exabyte, is not same as 1 exabyte to 1 zettabyte. It is on a logarithmic scale, which is expanding with an exponential curve. And if you see, the data has been expanding so much that we have already surpasses the human brain's capacity many years back directly. So this is where the human brain's capacity was, and now we are generating data which is many times above the capability or capacity of the human brain, or it is many times more than 100 years of high definition video plus audio. Now, with this huge chunk of data, what we are saying is how the data is getting generated. So these are some of the slides which talks about the data. I'm just skipping it. Uh, you already know how the data we're generating. Now, when we have this data, people started thinking, what do we do with this? So the first thing that they realized is, I don't know what to do with my data. So let us first gather all that we can. So that is where we started. So we started gathering whatever is possible. We started storing everything. So you go on an Amazon website, it stores everything that you do. Your login, your log off, your clicks, your likes, your dislikes, everything gets stored. Any activity that you're doing, any scroll that you do on a page, everything gets stored. So this is how people started using using data first. Let us first gather everything that we have. Now, once we have gathered all the information, what the data, what we started doing is We started putting in some dashboards, some visualization. We started seeing and understanding what the data is, what sales were, or how the sales look like last year, how the sales are looking last month, and so on and so forth. We started visualizing it. And now, once we started visualize it, we also started analyzing it. Now we can analyze any kind of data, but anything that is already passed might not give us value into it. So that is where we are talking about how the value is being generated and how difficult it is to get those things. Now, on the extreme left side, this is where we talk about hindsight. Hindsight is where we try to understand what has happened. Now, all of those things to understand what has already happened, it is called as descriptive analytics. And this has some value. So, for example, understanding how many customers are transacting on Amazon, or what is the value that is being generated, what is the revenue that is being generated last month compared to last year, compared to the last 3 months. Now, understanding what has happened gives you some value in terms of understanding how your business is doing, and it gives you some value. Now, this is very easy to accomplish. You just have to use the data to understand and answer these things. Now, a little more value is generated when we do the diagnostic analysis. Now, to understand why did it happen. For example, when a new mobile is launched and the mobile goes, the sales does not happen for that mobile, and that mobile launch was failed. Now you can do a diagnostic analysis to understand why that has failed. Now this is called as diagnostic analysis. From the descriptive analytics, we understood that the mobile launch was failed. People did not give a good response to that new mobile, and now using answering why did it happen that way is called as diagnostic analytics. It is helpful to understand what mistakes you did, or what were the good things, what were the bad things that happened, so that you make your actions correct in the future. Now this is where it gives you a little more value, and it is moderately difficult. Now, when we put in more into the inside part, so that is where we will understand what will happen. Now, this brings you more information. Now, if you would have worked on that mobile before launching and then understood what would have happened, that is where we are talking about predictive analytics. To understand what would have happened when we launch a product with so and so features, with this at particular price range, you do all of those simulations, you would have understood with some probability what would have happened when we launch a mobile with features XYZ with certain price range. Now that is where we call it as predictive analytics, answering what will happen. It is slightly more difficult, but it has more value. It will save a lot of cost to the company. It will bring in more revenue. Now, festival season is coming up. If companies use this time to predict what will be the sales of each and every category, that is where we bring more value by uh, providing companies a fair bit of demand so that they plan their actions, so that they plan their stocking. Well stock brings, if they would have predicted it properly before that event was happening, or before that event, they would have taken the right steps, right actions that will have prevented them from that failure. Now, this is where we talk about predictive analytics. The next thing is called as prescriptive analytics. Now, this is where we say, how can we make it happen? This is where we give a lot of these predictions, saying that for this customer, if you have to bring more sales, these kind of offers will work for these kind of customers. Now, if you are launching any mobile, if you want that mobile launch to be successful, target these customers. So we bring in prescriptive analytics in the form of giving recommendations. Customers comes on online website. We show the right product to the customer at the right time. That is where the sales can happen. So that is called as prescriptive analysis. And this has got the maximum value, and it is having more. It comes with a lot of difficulty as well as brings in a lot of value. Now, data science is where we try to focus on bringing value from the data. And this is where Some part of descriptive analytics brings some value. Diagnostic analysis brings a little more value. Predictive analytics and prescriptive analytics, it is the core which brings the maximum revenue, maximum value from the data for a company. Now, when people started to understand the value of company, this is what it came out. Data is the new oil. You might have already seen this part. I'm not going more into this. Now, how do we understand the life cycle of a data? So this is where we talk about life cycle of data. So the data first gets generated. Now, generation is what we do. So we generate the data. Customers scroll Amazon website, generates the data. Customer goes on
Ismail bhai,
Facebook, that is where it generates the data.
Ismail bhai, I'm sorry to interrupt. Just the screen was hang from the live stream. If you just give me 1 minute, please. Sorry for interruption. Yes, Ismail, you can proceed. Actually, we are back to live.
Okay, thank
Sorry
you.
for interruption.
So we talk about data lifecycle, which is where we start with how the data is generated and then used. So in this lifecycle, we have a lot of these opportunities in the field of data, which is present at every step of this. The first thing is the generation, how the data gets generated. So humans, our activities are the resultant for generating the data. Now there are some specialized devices which also generates the data, which captures the data, doesn't generate. So like CCTV. Now CCTV is where the data generation happens by capturing what is happening in the real world. Or we have sensors which captures the weather, captures the temperature, and all of those activities. Or sensors which captures the traffic movement. So this is where the data generates and then gets collected. Once the data is collected, we talk about the processing. Now, processing is where we say how the data that is captured should be stored. Now, we have data which can be stored in structured, unstructured, semi-structured. So there are different kind of data that can ways that can be stored. Now, to understand how we are storing the data, that is where we process that data based on how we are storing. Are we storing in 8 GB format, or are we storing in 4K format, or how do we want to process the data before we store? Now, the fourth is where the data gets stored. It is getting stored in big data systems or SQLs, or are we saving the data in a flight file or a CSV files? Now, once that is there, we talk about the management of the data. Management of the data is where we take a decision on should this data be stored in the live system, or should we move this data into archive, or if we are moving into archive, what kind of archive should be moved? Should we discard the data, or should the data be moved into a cloud? And all of those strategies about how we want to manage the data is what we see in the management. Now, the next is where we start doing the analysis. Now, analysis is where we do all of those things that we just discussed about, doing a prescriptive analysis or predictive analytics or descriptive analytics. Now, that is where visualization comes in. Visualization is the art which helps you see the data in the form of some good charts, maybe live charts, or some kind of front-end dashboards, which helps us see the data, how it is moving, or how it is performing, how the sales are moving, how the sales are performing, comparing it with different matrices. The next is about interpretation. How do we take decision on these things? Now, maybe I do some kind of analysis and identify a model which helps predict fraud. Now, this model, when it goes into live, it is helping us identify what are the different fraudulent transactions that are coming in. How do we manage those things? How do we interpret those things? Should we cancel these transactions? Should we block these transactions? And any of those interpretations that comes in from the analysis goes over here. Now, this life cycle of the data opens a lot of opportunities for building of careers into different stages of the data. So, to give you an understanding of how the big data landscape looks like, so this is what the big data landscape looked like 10 years back. So we have a lot of these business intelligence tools, visualization tools. We have analytical operations tools. We have core big data technologies, Hadoop, Hive, Cassandra, and all of those things. Now, as the data has expanded over the years, so have the companies expanded. Now, this is how the data look like, uh, or the big data landscapes look like, and this is expanding as we are speaking. More and more companies are coming in, which target certain aspects of the data part. So we have analytical landscape, we have infrastructure, we have seen this Amazon, AWS, Google Cloud, everything coming in to bring in all those things in terms of bringing out value from the data, having the right strategy of the data, having the right storage for the data, doing the right analysis, and having the right visualization in place brings you the complete structure or the complete life cycle of data, which helps in doing extracting value from the data that is being captured. Now, everything that we see over here is an opportunity for building a careers into, or bringing in all of these tools together opens a very wide areas of opportunities in terms of becoming a data analytics or a professional who extracts value from data by bringing in all of these tools together. Now, once we see that the life stages of data as well as the big data infrastructure, we see how the analysis, how the analytics is working. So for that, we have various different kinds of models which are being used and which are being categorized into different kinds of learnings. Now, the first thing that we see is over here, the artificial intelligence. Now, artificial intelligence is any technique that enables machines to solve problems how humans are solving problems. Now, any task which a machine is doing in a similar fashion where a human used to do that, now it is called as artificial intelligence. Now, robotics also comes under artificial intelligence because robots are doing what humans are doing, maybe like just making someone eat food. Now, helping people eat food, that is where a robot is doing that, and it is called as artificial intelligence. Now, a subset of artificial intelligence is the machine learning. The machine learning is algorithm that allows computers to learn from examples without explicitly programmed. Now, if you think of how a child learns, so if we show a child some fruits, maybe like we show some, uh, maybe we talk about two examples. We are showing a tomato and an apple to a child, and the child looks at tomato and apple and learns how a tomato looks like and how an apple looks like. Now, when a child is learning, we are not explicitly programming the child saying that, hey, if the object is red in color, round in shape, with maybe a green small stem, and it can appear in various different shapes and forms, we are not telling children that uh, if a object is red, it can be a tomato. Now, next thing is look for these attributes. When a human is learning, we are not training humans to learn different attributes of that product. Now, similarly, when a machine is learning from the data, like for example, when we are building a model which detects a probability of customer to buy a product. Now we see that a customer, will this customer buy a product or not? Now, if we are building a recommendation model, we are not telling machine to create these rules saying that if a customer is a male of age 35 to 40, then he will buy a product. We are not explicitly programming it. The machine is looking at the data and it is creating those rules on its own. Now, this is where all of those techniques are called as machine learning. Now, in machine learning can have various different kinds of algorithms, and the set of algorithms which are defined from how a brain works internally using neurons is called as artificial neural networks. So a human brain has neural network neurons, and we are creating those neurons artificially and then helping build these models. Similar to what we are doing in image recognition, we are showing some images and then saying that, hey, in this image there is a car, in this image there is a human. We are just telling the neural network saying that this image contains a car, this image contains an human being. But we are not telling explicitly that if you want to detect a human being, you should look at a human being, should have a face, a hand, and legs, and then he should be doing some kind of things. We are not creating and giving rules. We are just giving images and tagging those images saying that this image as a human. Now, internally, the architecture of that machine learning is having neurons which are artificially created by creating different links from different nodes. Now, this is called as artificial neural network. Now, a subset of artificial neural network is a deep learning, which has a deep architecture of artificial neural network. Now, maybe it has 50 different layers of artificial neural networks. Now, these deep learnings are being specifically used in autonomous car driving or converting speeches or understanding the text from a speech. If someone is speaking and then when a text is being spoken by customers, we are converting them and storing it as a text. Now, there are a lot of these discussions which are happening between a call center and the customer. All of those conversations get recorded. Now, if it is getting recorded and then you come again next time to talk about that particular conversation which has already happened by some other customer executive. Now, at that particular point, the customer has to explain the problem again to a customer care representative so that he can discuss on that problem. But instead, if we can record that conversation that happened last time and extract important text from it and then show it as a summary to the customer care when you call next time, the life becomes so much easier. Now you might have explained the problem, and that problem you explained on mobile, it gets stored, converted into text, and then we create a summary. And when you call again, the new customer care executive which is available gets assigned to you, but now he's equipped with the summary of the last discussion. Now, the summary of last discussion can help customer care come up to that understanding very quickly. He can now understand what you have already spoken, and he will be able to help you in a much better way, a faster way. Now, when he is doing this thing, they might have, when they are doing this kind of a thing to customer, the life of a customer becomes easier, the customer care life becomes easier. Now, both customer care as well as the user is saving so much important time over here. Now, when the time is being saved between customer care and the user becomes happy, the customer care is saving more time. He will be able to answer more phones now, and instead of making customer wait, now all of those time can be utilized in terms of providing a better service. Now, this is where we are generating value by using the data and providing the right solution to the customer. Now, this is where the deep learning helps us convert all of those text to summary, or even before creating the text, we are converting the speech into text. Going forward, we talk about some of the use cases of machine learning. Traffic prediction, search engine results. Search engine results, you might have been using Google for a long time, but search results are now present on each and every website that the customer or the companies are creating. Now, Amazon, Flipkart, they have their own search bars. Now, if you search for something, they cannot go to Google and then show something else, or they cannot search Google to show the results. You are searching Amazon, it should return the right products. And the important thing about search is it is based on context, it is based on time, it is based on how the customers are using that search. Can we give the search in multiple different languages? Or how can we understand if the customers are making spelling mistakes? Now, every customer who is using this website might not know the spelling of everything correctly. Instead of jacket, he might be searching for something else, but he might be thinking jacket in his mind. How can we understand what the customer writes and predict what is the right spelling for that and then show the relevant results? So that is where the experience of the search engine will get you the right revenues for the company. Now, of the 100 customers who come and search on the website, they are not more than one-fourth of those customers who write everything correctly. Now, if they just look at those one-fourth customers with the right spelling, they will not be able to serve the remaining 75% of the customers. Now, that experience defines the revenue for the company, and that experience defines the usability by the customers. And the customers might be coming back again and again. Next is online fraud detection. Online fraud detection, it is not just restricted to the finance industry, but it is also on e-commerce website. It is also into any of those places where people are doing a transaction. People are buying something. Maybe customer is buying a mobile, but he is placing that order with an intention to do a fraud. Or customer is buying grocery with an intention to do fraud. Now, when people are buying something, they do not intend to pay back or they do not intend to accept that the product got delivered. And can we identify these fraudulent transactions even before they complete the transaction, even before when they are searching for those products? Or better, how can we identify this fraud when a customer is creating his profile? A customer is creating his profile by giving some information, like we ask for mobile, we ask for email address, name, and maybe two, three different points. When the customer is creating his account, by the way he's typing different things, by the keystroke, can we identify whether this is a fraudulent customer who is creating an account? Now, as early as possible, if we detect the fraud, that is where we are getting more value from those actions. Instead of identifying that a customer has done a fraud after delivering a product where you have already lost the product, or if we can stop the transaction, that is where you are even stopping the transaction at the point of happening, even before delivering the product. Or better, if we can stop the transaction even before it started by just blocking those customers, those IPs from where the fraud accounts are getting created. Now, all of these things is opening a lot of these opportunities in risk analytics. Next is the medical diagnosis. So this is where we have a lot of these use cases in the field of healthcare. Medical diagnosis is where we look at the images, customers' history, customers' previous interactions with the doctor, and then based on those symptoms, we identify what can be the disease of the customer or the patient. And those diseases can be shown as a recommendation to the doctor, and the doctor can take an informed decision and not go into multiple different directions. Now, this helps in doing diagnosis very quickly for the patient as well as for the doctor. In the same time, the doctor can now look at more patients. If you know some of these very prominent doctors, they have a waiting time of like a month, like 3 months. Now, can we save time for these doctors who are very good in the profession by making use of data which can help take these interactions quickly? Can we store all of those previous discussions between the doctor and the patient and then create a summary? The doctor doesn't have to listen to all of those conversations again, and the doctor need not write all of those interactions and store it somewhere. Can we automate that process of understanding the transactions between the doctor and the patient in previous interactions, get created some kind of a summary which helps doctor come up to speed very quickly? That is where we use text and speech recognition. Text and speech recognition can be used in multiple different languages as well. So we have text and speech recognition in English, which got started a long time back, and now we have text and speech recognition into multiple languages. Now we are doing even in regional languages. Can we convert those handwritten text into online documents? Or can we convert these speeches which are being given and create books directly from those speeches? Next is email spam filtering. This is where we separate out the spam emails from the non-spam or important emails. Now, when you have a mailbox, you start getting a lot of these spam emails. That is where you stop using that email service. Now, if Gmail stops separating the spam and non-spam, nobody would use a Gmail in this age to send some kind of information, important information. So that is where Gmail keeps updating its spam filtering. Now, it cannot just be restricted to spam filtering for Gmail. Now, every company has their mailboxes. Every company needs to block their email box from the spams to stop attacks from external website, from external senders. So that is where every company needs spam filtering. Next is on image recognition. So that is where there is a very important use case that got implemented recently, is to identify arms in a bank. Now the bank has CCTV cameras, and all of those CCTV cameras are being installed at strategic locations. Now, can these CCTV cameras, which are capturing image, can also recognize if there is an arm, ammunition, like maybe a gun or some kind of a weapon, which is brought into the bank. Now, the bank is having people who are working over there. Instead of they raising an alarm, can we automatically raise alarm when there is an weapon brought into bank in and outside? We have personal assistants. Personal assistant is where you might have seen some kind of summarization of the task that you have for today. Next is automatic translation. You went into a new country, you don't know what to speak, and then we are able to see one second. So we are doing those translations automatically. Now this helps saves a lot of interactions to be seamless. These are some of the machine learning algorithms that we have. We have supervised learning, unsupervised learning, reinforcement learning. These are some of the different algorithms which are present, which helps us build these machine learning models. We're not going into details right now on this part. We'll continue with understanding what deep learning is as compared to a machine learning. Now, the difference between a machine learning algorithm and a deep learning algorithm is how these algorithms are internally built and how we are using them. Now, when we are using a machine learning algorithm to do some kind of a distinction between a fraud and a non-fraud, to identify a good customer from bad customer, what we have to do is, when we have the data, a user needs to extract and create features. Now, features are the data points. Now, if I have to identify whether a particular transaction is a fraud or a non-fraud, we might have some data points for that transactions. But from those data points, we'll have to also identify, create new data points. Maybe clean that data. The data might not always be in a proper format, proper shape. We'll have to clean those data points. And when we have such kind of problem we are solving, it might have limited features. Like when we are trying to build a fraud and non-fraud, we might know 100 different points of a customer transaction, which will help us build that thing. But when we have some kind of an image recognition, now when we are talking about image recognition, for an image, we do not have these features. Or if we have these features, there are millions of features. Now each pixel is a feature. Now each pixel will have a value for the red, green, and blue color which is there in that pixel. And if the pixel is maybe a 4K format, that is where it is having 4K into 4K pixels, which is like a very huge amount of features which are present. And each feature is having some value, and this value is on the red, blue, and green, the values for red, blue, and green. Now, that is where we see that output coming in from a machine learning compared to a deep learning. Machine learning can be used when we have limited data points. Uh, if we are working on building a model, even with limited data, we'll be able to use machine learning to build those models. But deep learning models, it needs huge amount of data to be trained because it is having so many features that it cannot learn if we are having less features. Now, if we have to build a model which identifies from an image if an input is a car or not a car. So for that, we'll have to first give a lot of these images already classified as some images which has a car, some images that do not have a car, and we have to give lot of these images for that deep learning model to work. Some of the use cases is where we talk about recognizing handwritten characteristics. We have some characteristics which are written. So we have like numbers, characteristics, characters, all of them written in a text. Can we take images of them and then identify what text it is? So that is where we talk about handwritten characteristics, characters. Next is voice recognition. We already know that. Another example of a deep learning is recognizing authorized signatures. So banks these days have all of these automated process where it can validate a signature on a checkbook by optical images being taken from the checks. You drop a check to the bank, the check gets scanned, the image is taken from that check, and then we identify what part of the check is having the signature, and then compare that signature with the signature which is present in the bank and identify with the right probability if that signature is same or not. Now we can have multiple different strategies built in. Now if there is a 100% match or if there is a 98% match, the check can automatically get approved. If the check doesn't match 98% of the time, maybe it matches 95% of the time, 95 to 97% of the time. So that is where we can have these checks sent to a human which will take the decision. Now, if there is mismatch more than 90%, the check can get declined. Now, there can be various different kinds of strategies that can be built in once we identify how much the check is, the signature of the check is matching the actual signature of the customer. How we uses that is the management decision. Once we build the model, that is where it comes in.
Ismail bhai, we are running out of some time actually. If we can round up very quickly, we have like around 7 to 8 minutes left. We can have some small Q and answers from the, I mean Q and answers, they will make it on the YouTube actually. Just I want to remind you about like we have like around 8 minutes left.
Okay.
Thank you.
Next thing is, this is where we talk about how we build a data science solution. So we start from business understanding, and then from business understanding, we go into data understanding. If we have some kind of business problem, what data do we have to solve for that? Now, once we do that, that is where we go and prepare the data in the format which can be helpful for building the model. The next is the modeling aspect, where we build different models. We use different kinds of machine learning model or a neural network model or an artificial neural network, any of those things. Once we build the model, we do an evaluation on that, understanding how that model is performing as compared to the real world data. The next thing is the deployment, where we deploy these models into the real world usage. Now, this is a complete end to end cycle of building a data science solution. Uh, for example, if we are looking at a problem, business problem, which looks like uh, questions which are like, who are my high value customers? Now, this is where we say that this particular question is for acquiring new customers, and for that we build a prospect model. Similarly, if we have a question which says that which of my customers are likely to grow their spends, or which customers are my customers whom or I need to focus on, that is where the goal is to increase the customer loyalty. And the model that we can use for them is a propensity model. So for different example questions, we have different goals, and for achieving those goals, we have different models. Now we have models which are like prospect models, propensity models, response models. Now each of these models has an underlying machine learning algorithm which helps us build those models. Okay, I think we'll stop at this point. We have some project case studies which have already covered into the discussion that we have. Instead of going into each and every case study separately, I've incorporated all of those into the discussion that we had. We'll take a pause over here and then see if we have any questions. We have 4 minutes left. So let me know if there is any questions for me.
Ismail, mostly the guys will make a questions, the students will make a questions on the YouTube chat. Actually, we are going live on the YouTube, so they will ask some questions there. We can answer them there.
Okay.
We have one question like the difference between the data and the information.
Okay. So data is where it is saved in some format which doesn't give you any idea or doesn't give you any concrete information coming out of it or actionable. When we use the data to extract some actionable insights from it, that is where we have the information coming out. So, for example, we might store everything that the customer is doing on a website. Everything gets stored. That stored uh, that storage of all the customer actions is called as data. Now, when you use that data, do some kind of processing, extract some kind of insights from that, that is where it's called as information. Now, you can have millions of data points stored as data, but it will not give you any value unless you do analysis of that, extract insights from there, and then those insights that are getting extracted from the data can be an actionable insights, which is called as information. Now, information is something on which you can action upon, or you can work upon, or which can give you value.
Yeah, it's very clear. There's one more question called, without deep learning, can't we generate a neural network?
Neural network and deep learning, these are both a subset. These both comes under neural network. Now, when you are creating a neural network, the network has layers. So you can think of layers as different screens. So when you have some data input and you want some output, you pass it through maybe a machine. Now, each machine is a neural network layer. Now, when you have a neural network with one layer or two layers, where the layers are less in number, it is called as neural network. Now, when you have more of these layers, it is called as deep learning. So, every problem that we have can be solved by all the things like machine learning, neural networks, and deep learning. But the output performance will differ. For some problems, the output will come in very good if you use deep neural networks. But for some problems, a machine learning will give you a better performance. So it's about what problem you are solving and what algorithms work fine for these kind of problem statements. it is not a universal that deep learning will always give you good results. Based on what data you have, based on what problem you are solving, sometimes deep learning will give you better results, or sometimes neural network give you better results, or sometimes both of them give you bad results and machine learning gives you good results.
There is one question, actually it's not a question, but it's asking of something like, I think deep learning deals with inner structure of the neural networks.
Yes, so deep learning is the neural network.
Yes, actually the time is up, Ismail bhai. Okay, the stream has like 7 to 8 actually, so they can ask the questions on the chat. I will share the link with you. If you have some time, please answer some questions for the students. It will be very helpful for them.
Okay, thank you so much.
Thank you very much, Muhammad Ismail, for your valuable time spending with us. Thank you very much. So, dear participants, feedback link has been already shared in the chat window. Please fill the feedback. It will be active till 8:30 p.m. only. So, we will be meeting tomorrow at 7 p.m. sharp with another interesting concept, that is importance of academic projects in the career growth. So, we will be meeting tomorrow at 7 p.m. sharp. Thank you very everyone.